Hello! In this video I will try to explain what shaders are and how you can use them to their full potential. I see many CT creators struggle with shaders, so hopefully this video will help them get a better understanding. A shader, sometimes also called a TEF or texture environment, is part of the GPU of the GameCube and Wii. It uses texture and lighting information to calculate what color a pixel on your screen has to be. Each shader can contain up to 8 normal stages and 4 indirect texture stages. For this video, I will only focus on the normal stages, since indirect stages can be difficult to work with. The editor I'm using is Brawlcrate, a fork and better maintained version of Brawlbox. Let's begin with the most common type of shader and how it works. Each shader in Brawlcrate contains 3 categories that can be modified: shader data, swap mode table and TEF indirect texture sources. None of these settings are really important except shader data. Under shader data, we can tell the shader which textures are used by its stages. Each texture reference is a reference to the material. In this case, the materials using the shader contain only one texture, so only reference 0 is enabled. Now it's time to take a look at the first and only stage in the shader. There are 4 categories here. TEF fragment sources, where we define what data from the material is used. TEF color output, where we calculate the color of the pixel. TEF alpha output, where we calculate the alpha or transparency of the pixel. TEF indirect texturing, where we can control the indirect stage. The first setting under fragment sources, texture enabled, should always be true if this stage uses texture info. The texture map ID tells the shader what texture to use, and the texture coordinates ID tells the shader what UV coordinates should be used to map this texture. These two are indices to the material layers. Because we want the material to control how each texture is UV mapped, it's recommended to always use the same ID for both settings. The last important setting of this category is raster color. For now we will always use light channel 0. Light channel 0 is part of the material and controls properties like material color, ambient color and vertex colors. Because these settings are correctly filled in by default after importing the model, I will not go into further details about them. The most important thing to know is that the raster color will contain the vertex colors. Time to take a look at the color output. The settings we are really interested in for now are selection A to D and scale. A, B and C are parameters for a so-called linear interpolation. What is a linear interpolation? Let's say we give A a value of 20 and B a value of 80. If we then give C a value of 0, the value of A is returned. Likewise, if we give C a value of 100, the value of B is returned. Think of C as an opacity slider for layer B in a photo editor. So, back to our simple shader. As you can see, A is 0, which means that this stage will be black if C is 0 as well. In shaders, the maximum value a color can have is 1. So if red, green and blue are 1, the color is white. B is our texture color. So if C is 1, which is white, the exact color of the texture is returned. C is set to the raster color. Simply put, this means that the vertex color decides where we are between black and the texture color. It multiplies the texture color with the vertex color, just like vertex colors are supposed to work. It's important to note that this equation is done for red, green and blue separately. The result of this linear interpolation is then added to or subtracted from selection D. Finally, scale is used to brighten or darken the result. So in summary, let's take this road texture, which we put in selection B. And let's make the left side of the road red with a vertex color, which we put in C. We perform a linear interpolation from A to B by the value in C, which in this case is the same as multiplying B with C. Then we multiply the result by 2, and the result is put in the output color of this shader stage. If there is another stage, output color can be used as input variable, but in this situation it is used to draw a pixel. The alpha output works in the same way. We take the texture and the raster alpha, perform a linear interpolation and return the result. I hope this video will help to get a basic understanding of what shader stages do. Of course, there's much more that I did not cover in this video, but once the basics are clear, the more advanced techniques are easier to understand. Good luck experimenting with shaders.